Even though very few students have joined, still we will start. We cannot wait for much more time. So let us start with the today's discussion, today's topic. So we started with the probability point. So in the probability, we have seen what is in the dependence and independence. So probability, it means that how likely an event might occur. That is, we are checking the chances that a event might occur. So here it means what are possible outcomes, and within that how our event will occur. That is given by a probability. So this formula we have learned. So then we have taken the example of flipping the coin, where possibility of head will be 1, that is 0.5, and possibility of tail will be 0.5. So that is, there are two outcomes, and out of that, if I am checking for the head, I can say that the 50% chances or 0.5 or half probability is there that the head might be there. So this concept we have seen. So here we are learning because we wanted to learn that what might happen. That is, we wanted to predict, consider when it comes to the enterprise based on the existing data, we are talking about the possibility of success and failure. So here, that's why we are learning this mathematical terms. So within that, first we have seen the concept of dependence and independence. Dependence and independence, it means that if consider there are two events, E and F. So if consider dependence, it means that the occurrence of E gives some information about occurrence of the F. That is, gives some information about the event F. That is, each occurrence might give some indications or might give some information about occurrence of the F. And independence, it means that occurrence of E is not related to F at all. Whether the E event occurs or not, it doesn't give any impact on the F. So this concept we have seen. Again, we have seen a few formulas and example by using a consecutive flipping of the coin. So then we have seen these two possibilities where we can say that event is dependent and event might be independent. So next we will start with the next point, that is a conditional probability. So conditional probability, it means that here it means whenever we are talking about independent event, so the conditional probability is that, so if consider here I'm having that this condition might be there, and there I'm talking about this condition may not be there. That is occurrence of the event. So when two events E and F are independent, so then by the definition we know that the occurrence of this event is probability of E and probability of F. Okay, so this gives the event that event EF might occur. So this is regarding the independence case. But what about dependence? So if they are not necessarily independent, that is here, that is probability of F is not 0, then we might define that is probability of E based on the F, that here the probability of E, if F is going to occur, then we might use this formula in order to get this thing. Get the formula, get the probability of E based on the F. Okay, if F is occurring, then E might be this. So it means here we are thinking the possibility that E happens, then we should know that F happens. So here in shorter terms or in other terms, so this is the improved definition. So conditional probability is probability of event occurring provided another event has already occurred. Okay, the formula for the conditional probability is here. If I'm having the conditional probability for A and B event, then we can say that B and probability of A and B, and then probability of B. So here we are talking about this conditional probability. So this is one of the cases of the Bayes theorem. So let us take an example for explanation of this conditional probability. So here consider there is a class of the students in the class. So the students of a class have given two tests of the subjects mathematics. Okay, in the first test 60% students got passed, while only 40% of the students passed both the tests. Okay, so we might be guessing that what percentage of the students who passed in the first test cleared the second test. This possibility or this probability we wanted to check. That is, I wanted to check based on the first test how many students have passed the second test. Okay, so here the condition based on the first test, that is I wanted to find out the condition for the F event, that is second test, based on the E, that is the first test. I know that both of the outcomes, that is how many students have passed the both tests. It means this is giving me that already the event has occurred, but I wanted to check for the probability that based on the first test, how I can check how many students will pass into the second test. So here, this is an explanation given to this. So P of A is the probability of passing the first test. P of B is the probability of passing the second test. And then, yes, are you able to listen to me properly? Any problem? Audio? Okay. And now I know that probability of A and B, that is occurrence of both the events, that is passing into the first test as well as passing into the second test. This probability is given by P of A and B. Okay, so conjunction is given here. So this formula is given. So now I wanted to check how many students have passed, that is who also passed into the first test. So it means success of A, and based on that I wanted to check for the second event, that is B. Then the probability is given by this formula. So after based on this example, let us put the values. So 40% students are there who passed into the both test, and 60% students are there who passed only first test. Then we can come to the conclusion that there are only 0.666. So it means which is equivalent to, that is based on the upper hand, so 0.67. So here we will make the conclusion that therefore approximately 67% of the students who pass the first test also pass the second test. Okay, it means that here based on my given data, that is if 60% students are passing the first test, out of that 67% of the students will pass my second test. This conclusion we make, or this possibility is there. Okay, clear with this conditional probability? Please go through the definition. So conditional probability is given that if consider I'm having A and B as two events and both the events has occurred, and based on the A, I can guess that how my B will, it means I'm applying the condition that if A has, if A, this event occurs, then how my B event will affect, or what is the probability that based on A, how my B will occur. Okay, it means here I am passing the condition that if A is true, then how my B can be true, or up to what level my B can be true. Clear with this example? So now let us go for the next point, that is Bayes theorem. So Bayes theorem, this is actually one of the most important points in the data science, or we can say it means most widely used concept. So Bayes theorem, this is also used for the statistics, analysis, or probability prediction, etc. And whatever conditional probability, right now we have seen that is one of the special cases of the Bayes theorem, or we can say the conditional probability applies Bayes theorem. So okay, so this it means in case of finding the disease or of taking the risk or investment, etc. In many cases, Bayes theorem is used. So let us see what this is. So Bayes theorem is very important statistical concept used in many industries such as healthcare and finance. So the formula for conditional probability, which we have done above, has been derived from this theorem. It is used to calculate probability of a hypothesis. Hypothesis, it means that imagination that I wanted to, it means we are predicting something. Hypothesis, it means this might happen, that case. Hypothesis based on the probabilities of various data provided in the hypothesis. Okay, so here it means that just like if consider previously in the first year, it means in 2019, I made this conclusion that those students who are passing the first test, out of that 67% students will pass into the second test. So this analysis I have made into the first year in the 2019-20. Then into 2021, again I come to conclusion that this might be the case. Again, I found this case is valid. And in the third year, that is 21-22, I might happen that this can happen. It means based on the previous data, I'm making some hypothesis that this will occur. Yes. So hypothesis, it means that this is a prediction, or up to certain level we can say that the prediction of some event. Okay, so let us see what this is. So Bayes theorem is the way of reversing the conditional probabilities. Reversing the conditional probabilities, it means that just like here, A and B has completely occurred. And then after getting the results, we are computing the probability that because of A, what is the probability that B might occur? That is, we are reversing the results or reversing the probability. So let us say we need to use the probability of some event E conditional on some other event F occurring. Here the statement says that let us say we need to know the probability of some event E conditional on some other event F occurring. Okay, so here we are talking about two events, and this E condition, how is affecting the F event occurring. Okay, so but we have, that is we only have information about probability of F conditional. Conditional, it means that this might happen or after this is occurring. Conditional on E occurring. म्हणजे E जर माझं आलं तर F असं असं होईल. That I know. That is, if E is occurring, then what is probability that F is occurring? Using the definition of conditional probability, then we will make the conclusion that here occurrence of E based on the F, then here the conditional probability of both the events divided by conditional probability of F event. Then next, conditional probability of E and F, that is the formula we are reversing. So previously we have studied the formula for this. We know that this it means that the multiplication of both the values. Okay. Then so this is equivalent to the conditional probability of F occurring based on the E multiplied by conditional probability of E and divided by P of F. So let me show you the previous formula. Yes, here I'm talking about. So this formula we have applied into here, and this formula, that is P of F is equal to P of E divided by P of F. This formula again we have used here. Okay. So now here we have applied this formula. So this formula we got. So it means that that is given by the Bayes theorem. So it says that if E is occurring, F might occur. Then we might consider that if A is not successful, then how F might occur. Okay. So here the Bayes theorem says that the event F can be split into two mutually exclusive events, that is E and F. Okay. F and E. Then F and E we write, that is here. Okay, I will skip to this. So I cannot allow for the selection. Okay, here this is, that is two events I wanted to check. F and E both are successful. That is E we got as a event occurred. And another possibility is that F occurred but E not occurred. Okay, so it means here not E. This probability also we need to consider. That is this event also we need to consider. Then we write, that is not E. This is given by the symbol. So not E. This we use this symbol in the probability. That is E doesn't happen. Then so what is probability of event happening of F? That is given by probability. If E occurred, then what is probability of F is happening, plus what is probability that E doesn't occur and F occurred. Okay, so let me show you some ways. Okay, here Bayes theorem says that, okay, I'm having two events, E and F. So it might happen that E occurred. Okay, occurred it or happened, or E not occurred. Okay, so here the probability of event E can be different, that is this might occur, or probability of this is not occurring varies. For example, if I'm tossing the coin, that is sorry, you're flipping the coin, then within that, if I'm suggesting that if I'm going for the head and tail, so E might be there that it is showing the head, that is showing the head into the coin flip, then this can be considered this is my first event. So within that occurrence of the edge, this will be having its own probability that E might occur. Sorry. And here probability that E may not occur. So okay, this is given by this symbol, that is right now whatever we have used, that H head is not there. Oh, sorry. I wanted to check for the head is there or not. So this probability is given by this event, E not occurred, and this probability that this might occur. So but both the addition of these probabilities will be 1. So right now in the coin we can check that this is 50%, 50%, etc. But instead of coin, if I take a dice and I am checking for whether 5 will be there or not. Okay, so occurrence of the 5, this will be having a different value. It means here 0.5, 0.5, this value may not be here for the probability that I wanted to say. So any possibility or any probability can be there. Then after that, okay, so after that, F might be some another event. For example, if I'm F might be the event that I am checking for the 6 during the second dice. Okay. So second dice throw or roll. I wanted to check whether 6 will occur or not. So probability of occurring of F. This might be dependent on, or consider that I wanted to say that the probability that F, if I'm going to roll my dice, the addition of first and second roll or throw will be 11. It means addition of these two elements. So if 5 is occurring, so here for taking to the 11, I may need 6, or consider that instead of 11, I will take 10, etc. So that, or take, let us take 9. Okay. So here, so I wanted to have this addition to be 9. So within that, if E is occurring, there will be different probability that F might occur. That is, addition will be 9. So I may have 4 in that case. Okay. So E is occurred, then F to happen the event, I need 4. It means here I am considering that E has occurred. Okay. E माझा अचीव झाला, त्याच्यानंतर मला F चेक करायचे की अचीव होतो का नाही. Okay. So within that case, I may go for F. Okay. E जर ऑफर झाला आणि F ची प्रोबॅबिलिटी काय की बाबा हा इव्हेंट ऑफर होऊ शकतो. And second probability I need to consider that if E may not happen, okay, किंवा E consider करा की ऑफर नाही झाला, then I may have the probability of at this point that I may have 1, I may have 2, 3, then 4 and 6. Okay, these are the probabilities. Then occurrence of F might be still there. It means म्हणजे हे पहिल्यांदा 5 आला आणि मला 9 चे ऍडिशन हवे. Out of these 5 numbers, any event can be there. Then if consider in the first I am getting 3 and in here I am getting 6, second row, then I can say that F might occur. If consider in the first row I got 4 and in the second row I got 5, okay, again I can say that this event has occurred. Okay, so it means that here still if E is not occurred, still there is a probability that F might occur. So then we need to calculate probability of F, that is F to be occurred based on if E is there or not as well. Okay, so whether idea is clear why we are checking for this formula. So then probability of event F is that when E occurred and when E not occurred. So in two ways, or by using the addition of these two, I can say that event F might occur. The same formula is given to this. Okay, probability of F that E occurred along with the F and plus probability that E may not occur. Okay, so this is given by the base theorem. Okay, and formula is also given here. That is here probability of, yes, that is for this formula we are using the first half of this, and for this probability we are using the second half of this. Okay, and that's why we are stating the base theorem that occurrence of event F can be split into two mutually exclusive events, that is F and E events might happen and F and not E events might happen. So if we write not E by using this symbol, then we can, it means if doesn't occur, then probability of F can be given by this formula. So please go through this formula. Yes, any of the student is having any question? Okay, so you might be wondering why we are having this lengthy formula. Just whatever our previous formula was there. So P of F got replaced by this formula, and this formula again replaced by P E of F, F of P. So the each one we are having the split up, and the same split up is used here. So let me show you. Okay, so this is my formula, occurrence of E and F. This is independent and conditional on F. This is my conditional formula, that is E and F event occurrence. Then here, the same formula we used here. So E of F equal to right now P of E comma F. That is event E is happening and because of F. Then here the same is given. So instead of this one, P of F, so E of F, we replace this formula. That is that is F is conditional on the E. And then based on this formula, the previous half, we come to this formula. Okay, if you are clear with this, so now let us go for example now. So, okay, you might be wondering why we are talking about this Bayes theorem. It means what is probability? It means why we are studying the probability that because of E, F is occurring or not. So here this is taken because we wanted to apply this to the data science in healthcare or any finance, etc. If consider that condition A is occurring, then what is the probability that F might happen? That is some another condition I'm talking about, some another risk or another failure, or another target, objective, etc. So let us go for some examples. So always these are the probabilities of some test result, some conclusions, some remarks, etc. So here I have taken an example of the test cases in the healthcare. So for example, let us assume that there is an HIV test that can identify HIV positive patients accurately 99% of the time. Okay. So accurately it means that always accuracy is not 100%. It is always a 99 or less than 100%. So also accuracy also accurately has negative result of 99% of the negative people. So here there are two terms. Okay. First is that test is positive and this patient is HIV positive. Okay, these two are the different things. It means that yes, if person is positive, it doesn't guarantee that the person might be HIV positive. टेस्ट पॉझिटिव्ह आले म्हणजे तो पर्सन पॉझिटिव्ह आहेच असं नाही. दिस इज अ टेस्ट रिझल्ट. पॉझिटिव्ह आला आहे अँड दिस प्रोबॅबिलिटी ऑफ हॅव्हिंग द HIV पॉझिटिव्ह इज 99%. ओके, मग इथे मी म्हणू शकते की 100 मधल्या लोकांचे जर समजा टेस्ट जर पॉझिटिव्ह आले तर त्यातले 99 लोक HIV पॉझिटिव्ह असतात. एक असा पर्सन असू शकतो की पॉझिटिव्ह आला आहे पण त्याला HIV पॉझिटिव्ह और ही और शी इज नॉट HIV पॉझिटिव्ह. Okay, so it means that if test result are positive, then that person might be HIV positive. That is a 99%. Similarly, the another statement says that if tests are negative, then having HIV negative. Okay, negative result, we can say that probability is also 99%. It means that if I perform test on the 100 people and uh, whose results are negative, test result is negative, out of that 99 people will not have HIV, but the one person might be HIV positive. Okay, test result is negative, but the person is HIV positive. The probability is 1%. Okay, and the overall population. So this is the actual result. So test result says that there are 0.3% of the people are there who are HIV positive. Okay, that is the actual result. How many people are HIV positive? Okay, the scenario is clear to you. So now we are going to apply for the Bayes theorem. So actually this might, is this clearly visible to you? So okay, A, it means that the person is HIV positive. B, it means that the person is also tested positive. Okay, then probability of A to occur is 3%. That is, sorry, we need to take the clear look. This is a 0.3%. Okay, 0.3%, it means that 3.003. Okay, then probability that out of B, it means A might occur. म्हणजे based on B, if A might occur, म्हणजे माझ्याकडे जे 100 people आलेले आहेत ज्यांचे टेस्ट पॉझिटिव्ह आलेले आहेत त्यातले ऍक्च्युअल A ला सॅटिस्फाय होणार आहे, those are 99%. So this will be the P of B based on the event A, sorry, probability of A based on the event B is 99%. Now we wanted to calculate that what is the probability that test might be positive. Okay, so P of B, probability of testing positive when HIV positive, plus probability of testing positive when HIV negative. Okay, remaining is the mathematical calculation. Please go through the calculation. I will give you a minute and then we will go for the next point. I think I shared complete screen because of which you are unable to read. Please read this. I will share the number. So, okay. Before starting to the next, let me show you the textbook. It means this copy is clearly available. So this textbook, let me show you the home page. Okay, this is the first textbook preferred by the university, that is data science from scratch. So each and every chapter is not available within this. So you can go to the index. So within that, we can see the most of the points, that is I'm referring to the first, so second and third chapter. Okay. Most of the points are available, but these points are actually a separate chapters into this book. Okay, just like visualizing data, linear algebra, statistics, probability, hypothesis. So these are actually acting as separate chapters here. And these are the points in our syllabus. Okay, let me show you. So first, my preference will be you should go for the textbook. If you feel that here, just like I can see the linear algebra is a point in the mathematical foundation. So whereas in case of this textbook, we are having linear algebra as a separate chapter. Then, sorry, in here, statistics, it's separate point. Then probability, it's separate point. And then here, where is hypothesis? Yes, hypothesis and interference. So these are the separate points in the probability, in statistics and linear. So these are the main 4 points. So whereas if we're referring to the textbook, so here in the linear algebra, we are having vectors and matrices. In the statistics, describing single set of data, correlation, Simpson's paradox, correlation and causation. So these are the points. Main point is the probability, and within that we can see the 6 points. Again, hypothesis and interference. So these are the points we are referring here. P-hacking, statistical hypothesis. So these are the different points into this. But whatever our remaining contents are there, so we cannot refer to this book directly. And for this contents also, I will not recommend this book only. Okay, I will not recommend this only book, because here whatever we are learning about probability, etc. So this doesn't give a clear idea. Okay, for example, if I'm talking about the conditional probability, it takes an example randomly, and formula evolution is also not clear. So for the first reading, you can take this, but for the study, please refer to the notes or some other sources, etc. But concept will remain same. Okay, let us see how we can go through the examples, etc. So here, okay, let me elaborate this on this example. So here, when we are talking about this example, we wanted to learn about Bayes theorem. Bayes theorem says that if I'm talking about event B, which has already occurred, and I wanted to check the possibility of this event, then just like in the previous cases, we are talking about this, that not E, etc. It means in the conditional probability. So conditional probability also uses the Bayes theorem. So let us see what it says. Okay, so A, it means that the person is HIV positive. Then B, it means that test is positive. Okay. Okay. So then next. So I wanted to check the probability of A occurrence. There are total, it means probability of this event is 0.003 percent. Okay, it means the event A might occur. Then I wanted to calculate for event B might occur. So here this says that 99% of the positive cases will have HIV positive and 1% case is there which is gives the test positive but the person is negative. So when we look for this formula here, condition probability of P of B, that is A, is 99%, that my test is positive and the person is also positive, that possibility is 99%, or we can say 0.99. Okay, this is the probability. So I will remove the percentage. We are talking in terms of probability. So I wanted to check how I can guess that whether possibility of having the event B. I wanted to check when the possibility of test will be positive. So it goes for two cases. That is those cases which are having positive, that is those persons which are HIV positive and those persons which are not HIV positive, negative. It means right now we are talking about all the cases. So here this explanation says that probability of testing positive when HIV is positive, person is HIV positive, and I wanted to check when HIV negative person plus we have tested that positive person. Then in such cases, I can say that the probability of having it is positive plus person is positive. Then we can go for multiplication. Point will always remain here. Then another possibility is that we have tested that person as a positive, but that person is HIV negative. Okay, what can be the probability of having the negative probability? Yes, any idea? Here, the statement says probability of testing positive when HIV negative. Okay, we are talking about right now the cases where we got a 99%. That is, whatever 99 positive will be there, those cases we are considering. But whatever 0.1% remaining is there, those 1%, that is, we are talking, consider that I got 100 patients data as a positive. Out of that 99 we considered and one remain to consider. So let us take here one I wanted to consider. So 0.01 I will consider, multiplied by that. Here the person is negative. Negative, here the person is positive. This probability is this. So I can say that not A. So person is not positive or person is not HIV, person is HIV negative. That will be 1 minus 0.003 point should be at this point. So this is the probability that person is negative. So then let us calculate this. So this will show me the exact values, and because of which we are having this probability, and this will leads to the 1.3% of the cases are there where I can see that the person is positive, that is person will be positive, that case is 1.3%. Okay, then I want to check, that is someone is being HIV positive plus the person is tested positive, that probability we will have as a 22.8. So we wanted to check from the complete population. Then for this cases, we can use this probability. Clear with this? So please go through these points. Let me know. Still with a so whatever this probability 6 concepts are there. So these are the most widely used concept, that is random variables, continuous distribution, normal distribution. We covered up to first three. Still remaining three are there: random variables, continuous distribution, normal distribution. So whatever the case, like a roll, dice, etc., we have taken, these are the, it means random, we can say random, it means that discrete, continuous nahi hote. So then random variables, when there are multiple events are there, then we cannot remember exactly when our event is one or when our event occurred or when not, etc. So these remaining points we'll see into the next lecture. So please go through these points, go through these slides, and let me know if you are facing any problem. So I will only share the slide and will take the attendance. If you are having any problem, please let me know, and please don't leave the meet. Let me take the attendance. I'm still on. Please don't leave the meet. Oh, you don't need to write the call. It means your roll numbers. I will simply take attendance from the participant list. Unless and until I say, please don't leave the meet. I will simply take attendance within 5 minutes.